tell you when, keep going. You got a long ways to go. We're still flexing. Keep going. You're not gonna flip it. There, it's good. Bring it down just a little bit. There. There. There's your flex. That's flex. All right, hey, Metaltech 4x4. We're under the GX470 right now. Outside, we're flexing it out with the forklift. It's always fun to flex a truck with a forklift, see our true flex off-road. Years ago, God, 2008, or I don't remember the exact year, we made the original airbag conversion system to be able to convert airbags on the back of a 470 over to coil springs. That's a bolt-on system. We had a local customer that wanted to get a conversion done, and we were gonna weld pucks onto his truck when we realized, we're like, wait a second, there's nice little holes in this perch. We can put a bolt on here and we can bolt this conversion kit on the truck. And what that basically does is, the conversion kit is basically this system here. And it is a center system that is welded out of steel, and then it has an external, or has a full lid put on it so we can actually bolt this thing on. And then it has an outside isolator, this part, which then handles the pigtail of the spring and allows it to seat and sit correctly on the truck. And so without these, there's nothing holding the spring correctly in its place. And so as a manufacturer, we actually build things here. We actually look at problems and come up with a solution and build it in-house. In beginning of this year, we had a need for quite a these from our vendor, but like a lot of things right now, vendors are way behind in their supply. And we got about a 20+ week lead time for these from the vendor. And that just led to us saying, well, what can we do? Now's maybe the time to redesign this piece and go with something a little bit better. So that's what we came up with.
All right, so we've drawn the part. It's made out of a couple of key features. The key thing here is that it's got this upward sweep on this plane here, which is giving us this ability for the pigtail of the spring to sit and sit nicely. So we can't just make an exact version of what we did before, since we're doing this out of ultra high molecular plastic. So we've designed this to be a little bit different. The big thing is that we made the flange wider, and then we're compensating a little bit on the inside. We're gonna make this a little thinner, since the rubber stretches, the polyurethane stretches, whereas the ultra high molecular plastic does not. So this inner bore, we're gonna make this a little bit tighter. But the part itself, we pretty much got it here, modeled up, and the bottom side of it is completely flat, which is gonna be important for the way that we're actually gonna make these things. We're gonna be machining these on a 3-axis CNC mill in-house. And this bottom part's pretty important, being completely flat, because we're actually going to hold these. It's always one of the biggest challenges in machining, is how do you hold something? So we're going to be holding them with vacuum, actually. We're going to use a vacuum system to hold this, to build, machine quite a few of them at a time in a custom-made fixture. So this is the finished part in CAD, so I'll go ahead and bring this over into my CAM software. We'll run some tool paths on it, and then we'll get it set up into a custom fixture. We'll machine the fixture, which will be really simple, and then set it up in the mill to run it to actually make these things. That's the other 1/2 inch. We don't want that one. There it is. All right, so we're next to our mill. This is a Haas VF2 Super Speed, and this thing gives us a lot of flexibility in our manufacturing at Metaltech. If we need something, we can actually make it ourselves a lot of the times, and that's exactly what we're doing with this coil isolator that we're building for the bottom of our coilover system. So to solve our supply issues, we're actually going to be milling these parts from 1 inch thick ultra high molecular plastic. That's going to be like a cast piece of plastic, a billet piece of plastic. And we're going to machine that into our finished part. So we're going to be using a couple of really cool tools to do that. One of the tools is this very specialized 1/4 inch end mill that has a really high helical turn to it, which is designed to just rip the plastic away and pull it out really quickly. It's also a single flute. It's almost like a router bit, but we're going to be spinning this thing around 10,000 RPM, so it's going to be moving pretty fast. And then our other tool that we're going to be using for this is going to be a 1/2 inch end mill that has actually been 2 flute that's been custom ground on the corner. And it's super important because the original part that we have
has a large radius that we have in there that we need to have as a relief. Otherwise, it creates a stress riser where the plastic might actually crack, and we don't want that to happen. So we want to create that as well. So we're using a 1/2-inch end mill that has a custom radius milled into it. All right, these are carbide, very sharp. We don't want to drop these on ourselves. So I'm going to put this one back in the mill, so it's good to go. We can use this. In order to hold these, we're going to be machining these parts. So let's take a look at the finished part real quick. So this is what we've been using all these years, and it's time to improve it. We want to make this flange a little bigger. You saw that we did that in CAD, and this is the new part. So we've actually made the sides considerably wider than what we have with the polyurethane, and then we're going to an ultra-high molecular plastic. And so this is a hard ultra-high molecular plastic that is extremely strong and very thermal stabilization for what we're doing. And then we're going to be cutting these out of these 1-inch chunks of ultra-high molecular plastic. So these are going to be being loaded on the mill, and we're going to cut them out of these pieces. So the challenge in machining always is how to hold the part. How do you hang on to it? And obviously this is a round thing, so how do we hang on to this as a vacuum? Let's take a look at the fixture we have in here and how we make these things. So these are custom-made vacuum tables that we actually machined for this application. We're using a Venturi system from Pearson Work Holding, and each one of these tables has its own vacuum generator. And each one of these black round things is representing one of our isolators. And this is a gasketing, which has a small hole that goes down below into the vacuum system, which is pulling vacuum, which is holding our plate in there. And then we have these dowel locators on the fixturing to hold our part in place while we machine the parts. So we take a plate such as this, and we load this baby in this way, and we load the other plate in as well. Like that, and then we'll be turning on the vacuum, and then the vacuum is going to hold these down and allow the machining to happen without having to have anything else on here. Now we're going to put a couple of safety clamps just on the corners, just for a few spots, but we're just going to do that for just for added safety in case vacuum should start to leave. We have the ability to have those hold the chunks of material in there, because these are actually kind of expensive, and when one of these gets loose, we end up scrapping the entire part, which we don't want to do, or worse yet, break the end mill, which these also are expensive. So I'm going to throw a couple of can't twist clamps on here, and then we'll kick the vacuum on, and then we'll start machining the part. Good. There's our code. And we're going to go ahead and start. Going to do a tool change and go right into the part. Okay, so the end mill is currently machining the part, and what it's doing is cutting the center features into each one of these plates. Each plate cuts 9 parts. We get 9 parts out of each plate. And what we're doing to maintain vacuum is the whole underside of the part is like that. And obviously if we cut through, we'd break vacuum. And so what's going on right now is that it's machining the center part almost all the way down, and it's leaving 12 thousandths of an inch at the very bottom. So we're leaving a 12 thousandths floor on the bottom. If you see me flex this, you can actually see the floor show up. And then what we do when the part comes out, we're able to come in with a deburring tool and poke that into the floor, and then we're able to cut the floor right out in one shot. So there's the floor, the little center chunk just came right out. And now we have our hollow piece, and it maintained vacuum the entire time when we did that. So now we can go ahead and finish deburring this part and getting it ready to be a finished piece. And they have to be done by hand. There's ways to do CNC deburring, but we're going to do this by hand because it takes a little bit of time to run each one of these parts. We got time to knock these out. So we're just going to come in here and nicely just remove the, take these little burrs off. So there's a finished part. It's going to get dried off. It's got the coolant on it from the manufacturing process. And all the coolant is, all that white, milky looking stuff in there is actually emulsified oil and water that's custom made for CNC machining. If you like what we do and some of the videos we have here, you know, like and subscribe our YouTube page for us. It makes a difference for us. And if you're finding value in some of our stuff that we're putting up, share it with some other people. It's certainly appreciated. It makes a difference for us, and it encourages us to make more content. All this code going by here looks like the Matrix. It's called G&M code. And this is what's telling the machine where to move and what tool to be using. This particular machine, we can really see easily what's going on. We got a 7640, so 7,640 RPM is what we're running. And then we have a feed rate of 130 inches a minute, which is moving pretty good on plastic. We could probably push a little harder, but since we're cutting with a vacuum holder, we don't want to push it too hard and have it get yanked down to the vacuum holder. So right now the machine's running at full RPM, full capacity, not full RPM, but very little spindle load on the mill itself. And these are our current active codes that it's currently doing right now. These are actually codes that have gone by and it's remembered what those are. And if we look at our diagnostics, we can look at what's going on with the mill. And spindle's nice and cool, very low vibrations happening. Everything's looking really good. All right, so the machine chips, from the CNC machine, all the chips that are coming out of it are gonna be going back to the recycling facility. All of our ultra-high molecular that we're using, all this material is actually what's referred to as repro. And repro is repurposed, it's so in other words, it's basically recycled materials that's making our ultra-high molecular plastic. And we're building all of our parts out of that. And so when we're done, all these solid pieces and then all the machine chips from the mill itself will get packaged, and we're gonna be giving this all back to this plastic supplier, and then it'll all go back into the system again and get reprocessed back into more repro. So that's the final part. So we got them all done. The pieces are continuing getting made. Again, think about Metal Tech. We actually do all manufacturing right here in our own facility here in Oregon, right here in the United States. So we believe in U.S. manufacturing. We appreciate your business. Thank you.